Hi and welcome back. So I received a package from Belgium and it was sent to me by Conventional Memories, who's a member on the Vogons forum, and he saw my work on the T1600 power supply and he very kindly wanted to donate me one of his XT-IDE boards, especially made for the T1600. It slots into the expansion connector on the machine. Comes with a nice 3D printed front, and you can just slot in your compact flash card and it plugs into the machine like that, and it works perfectly. Absolutely flawless. So thank you very much for this. This is awesome. He sells these on eBay, and I'll put a link to his eBay in the description below, so you can check him out for yourself. He also sells boards for different Toshiba models. I believe the T1100, the T3100, and some others. But I'll link all of them down below in the description, and you can check it out for yourself. So thank you very much again to Conventional Memories. But that's not what this video is about today, because he also sent along two of his T1600 power supply boards and asked me if I could check them out. So that's what we'll be focusing on today. So yeah, he sent these along to check out, and he sent along both so we can swap around some parts if need be. Both have been worked on before. This one has been fully recapped. This one is obviously missing some parts, the capacitors and some transistors over here, and I'll address the elephant in the room in a minute. This board looks, well, pretty much okay. It has some exposed copper, but that shouldn't be any problem at all. Caps have been replaced, as I said, by Rubicon caps. I prefer to use Panasonic brand, but Rubicon is just fine. It's genuine good brand. And it looks like this board is pretty much okay. Not a lot of damage. Actually, pretty much no damage at all. And I'll start with this board. And probably use this board for parts. I don't know. I don't even know if I can fix it, because there's a giant hole where a capacitor leg should go. And there's a bodge wire here, and there's, instead of a fuse, there's a bodge wire here. But yeah, this worries me a lot. I don't know why that hole is drilled there.
Hi, Future Tom here. I'm interrupting my past self to say that I have inquired about the hole in the PCB, and as it turns out, it was drilled there to get rid of a short and some charred PCB material. Now, cutting or drilling out charred fiberglass is actually the preferred way to repair this kind of problem. So, it's actually just fine to do this.
But yeah, this is a 4-layer board, so there's an internal power plane and internal ground plane to this, and I don't really know if there's a break between the inner layers, because it's not just one solid internal power layer. There's more layers, and they're separate. You can just about see them right there next to the... Wait, let me point that out. You can see right here and there, when the light is shining on it, there's a little light green line, and that's a part where there's no copper on the internal power plane. So I really hope there's no internal power plane separated, or multiple power planes over here. And I really hope that nothing got shorted when drilling through, because this, yeah, just... So yeah, as I said, I'll probably use this board for parts, and maybe we can get this one working. I don't know. But I'm having better hopes with this board, so we'll start with this one first. And we'll just check out what's going on with it. So first I'll solder an LED to the DC-in LED over here and to the 5V B regulator, so we can check out what the board is doing. And then I'll probably solder on some component legs in various locations, like over here, and over here, and over here, and where is it? Over there. So we can check out the different voltage rails on the oscilloscope, see what it's doing. Probably we'll have to check out if the oscillator is good on these boards. So let's get cracking. Okay, I had a thought, and since I know that this one isn't working, Conventional Memories told me it isn't working, I am first going to get the schematics and start beeping out some of the stuff that I have seen fail on my power supplies to just check and see if everything's connected. So if we get the V main over here and if the resistor divider over here is connected and that kind of stuff. If there is any damage to the PCB traces, it will most likely be in this upper part here. That's where the capacitors are, that's where they leak. So most corrosion damage is going to be over here, as you can also tell by the blank traces, the bare copper traces. So I got the schematic, I got a pen to mark some stuff, and my multimeter, and we'll put that in continuity mode so it beeps. And let's just start probing around a bit. So at least the traces for the main boost converter look okay. Next up, let's check out the positive 12 volt boost converter. So we should also have Q2 and Q3, which are these two. Those should be getting the main supply, and that's fine as well. So I'll put an LED and a resistor on this pad and on that pad, and that way we can tell when IC13 is turned on. It takes a while for IC12 to power down IC13, and I don't really feel like having to get my multimeter and probing it every single time. So okay, and okay, so IC13 is now powered on, that's normal. And after about 30 seconds or so, it should power off. And the DCN LED should just stay solid, shouldn't blink. It is only when you press the power button, then the IC12 turns on IC13, and that's when it starts to send signals to IC3 over here, which then drives all the MOSFETs. And it's driving the MOSFETs through IC5 and IC11 over here. So when I now try to turn this thing on, it errors. Okay. So this is similar to what my power supplies did. Alright, everything's connected. Okay, so that kind of tells me that Q4 is probably a goner. And that means we have to remove it. Next we are going to put this in the tester. This is an NEC2SK814. Okay, so it's actually good. N-channel MOSFET, gate, drain, source. Yeah, that's correct. Okay. So then why isn't it switching anything? Now, it could, of course, also be that Q2 and Q3 are damaged. And I have seen these two burn out on my power supplies, so that might actually be the case. Which would be unfortunate because they are still available. You can order them from the UK, but with the Brexit stuff and everything, and the lockdown they have at the moment over there, it will probably take a while to get those. And also they are very expensive. They're like €5 a piece or something like that. So yeah, not really cheap transistors. And it looks like these have been soldered on before. But what do you know, this one is good as well. Interesting. Let's see what it has to say about this one. N-channel MOSFET. Okay, so this one is good as well. Okay, so we checked Q2, Q3 and Q4 and they are all good, and diode 3 is also good. And we are getting oscillation on Q4, so Q22 and Q23 are probably fine as well. So let's just put a check mark on those so we know they are okay. Right. Either we don't get any 18 volts through here, but we measured all the connections and well, we didn't measure the resistors. I will do that in a moment, but they are fine, I can guarantee you. And the other thing that could be happening is that P12VEN is being actively pulled low all the time. So it gets pulled low, and that is simultaneously with the 18 volts coming online that is being pulled low, and then it is getting a PWM signal, and then a whole load of nothing. Maybe yeah, not doing anything at all. So it's detecting some kind of error somewhere else. So this is the negative 22 volts. I'm just dropping paper everywhere, which is also a P-channel MOSFET, so it also gets pulled to ground to switch the MOSFET on. That's not doing anything at all. Okay. So we already checked these MOSFETs and this diode, and that's okay. So those are all fine, and the resistors are fine, and we're actually getting 12 volts up to here. So this is working, and also this transistor is at least being driven. So there is a PWM signal on the gate here, but we're not getting any output because Q2 and Q3 are never enabled. And for the VCC 5 volts, we're actually getting some PWM, and Q1 is enabled automatically through the 18 volt bus coming in here and resistor R19, so that that part also works. We at least get some voltage. The controller just shuts down before it can ever reach 5 volts. And I was thinking about this for a while, since the LCD voltage converter is never turned on, and I saw that behavior on one of my power supplies, and it was caused by the negative 9 volt not being regulated properly. So I was probing here and here after I measured that we actually got 12 volts up to here, and we do get that. And this MOSFET Q5 was receiving a PWM signal, so the transistors are working. You can see it switching. But I also put a probe right here, and we're not getting any signal there. And I have that on the oscilloscope right now, and as you can see, the yellow trace here the yellow trace is actually the gate for the MOSFET, and the blue trace is the output. And if I turn off channel 1, so that's just noise from capacitive coupling or inductive coupling or something, but we're not actually getting anything. If it's switching 12 volts, then we should see 12 volts on the other side, but we're not. So that has led me to believe that this MOSFET, which was over here, so that will be MOSFET Q5 over here, that MOSFET is not working. So I desoldered it, and I cleaned up the holes already, and I got my component tester, and if we put this into the component tester, this should be a MOSFET, and it says it's a capacitor between pins 1 and 2, and that makes sense because the gate of a MOSFET behaves like a capacitor, and 640 picofarads, that's right about the gate capacitance. Now, so this is broken. So I'm going to solder in this MOSFET, and then we are going to recheck the signals on the oscilloscope. So the new MOSFET is in, we connected the probes, and now we reconnected the power supply. So let's plug the thing in and reset all of this. Come on. Yeah, that's probably good. And wait for the LED to go off, to turn off. This is what makes it extremely time consuming. Every single time you have to wait 30 seconds for that IC to power down. There we have it. And let's single shot that again. Right. Now we're actually getting something. So that's right about minus 9 volts. Okay, great. So now we're probing the negative 22 volts. And let's single shot that. Okay. And here we see the exact same thing again. So the transistor is turning on and off, and there is always 12 volts supplied to it. Right, so we are getting 12 volts, but we're not getting any output. Yeah, exact same problem. So that MOSFET is also most likely a goner. Yeah, it's a 2SJ133. Alright, just to prove that this one is actually dead. Yep, dead as a doornail. Okay, everything's connected, the test pins are connected, and the LED is off, the scope is ready, and let's go. It's running. It's working. I will prove it. It is absolutely fine and it's working. 5 volts, 12 volts, short circuit. Ha ha ha. I'm an idiot. Right, I am going to remove that test pin. That is not good. Now let's try this again and see if I haven't destroyed anything. That would be really, really stupid. Come on, little LED, turn off. Oh, great, thanks. Yeah, I destroyed something. Ha ha. Damn it. Well, at least we know where the problem will be now, I guess. God, that's so stupid. Ah. Well, let's look at it this way. Just let me make all the screw ups so you don't have to. Oh boy, that's a lot of voltage. Alright, pretty sure I know what I destroyed, and I'm pretty sure I can fix that, because I happen to have another one of these diodes. Alright, well, luckily, when I ordered diodes for my power supply, I ordered 2. When you're testing stuff like this, there's always a risk of you breaking things that you just fixed. It actually makes a lot of sense to order twice as much as you need because of the shipping cost. I'm always paying €5 or something for shipping, so it just makes more sense to me to order 2. And if it blows up again because it didn't fix the problem, or it blew up for a reason. It always blows up for a reason, but it blew up because of something in the circuit is still broken, then I don't have to pay the €5 shipping cost for like 20 cent part. So the ones marked A6, they are BAS16 in a SOT23 package. Right, so that's in there, and this is the one I just put in. So nice and clean, nice and shiny solder, good solid connections, no blobs or anything, so that's in there good. And now, if we turn it on, I am fairly sure that it will work again. Power it on, and it's on right now. It's running. So, as I was saying before, this is now working. And I shall show you that it is working. So, on the multimeter, we get... Don't short circuit it this time. Negative 9 volts. Positive 5 volts. Positive 12 volts. And also negative 22 volts. And with that, I declare this power supply fixed. So 1 down, 1 more to go.